Good evening everyone. Our next topic is conservation of linear momentum for a system of particles. Dear student, in the previous lecture we come across an equation for our vector r, and we define r as summation over I mi ri vector upon sigma mi. In the denominator, sigma mi was nothing but the mass of the system. It can also be written as sigma I mi ri vector by m. Now dear student, take this m with this r, we will get mr vector equals sigma mi ri summation over I. Dear students, differentiating both sides with respect to time t, we will get m, as it was already stated in Newtonian mechanics, m is assumed to be constant. M is constant here means it doesn't mean the mass cannot change during the motion. Mass can change. For example, in rocket, mass can change. Here m is constant means our object is moving with normal speed, not comparable to the speed of light. Or I can cautiously say that I am not in the domain of theory of relativity. That's why we can take m outside the differential with respect to time. So d r by dt equals, again dear student, sigma I mi is considered to be constant, mi d ri dt. Students, this dri by dt is the rate of change of position vector of the ith particle with time. It is nothing but the velocity. Sigma I mi vi vector, it's the velocity of the ith particle. Velocity of the ith particle multiplied with the mass of the ith particle is the momentum of the ith particle, and if the momentum of the ith particle is summed over I, this quantity is the vector sum of linear momenta of all the particles. Suppose my system has 10 raised to power 6 particles and they are moving. Then this term, term which seems to be single, it is actually 10 raised to power 6 terms. And these 10 raised to power 6 terms are very complicated. Complicated in the sense, dear student, this is actually m1 v1 plus m2 v2 plus m3 v3 up to 10 raised to power 6 times. Why it's so complicated? Because student, this is not the sum, this is the vector sum of those quantities which may or may not change with time. If we have to find out this sum, what we have to do? We first have to look at the first particle. We have to measure its mass and velocity. Then we have to measure the mass and velocity of the second particle, then for third, then for fifth, and so on up to 10 to the power 6. And then we have to add all these terms vectorically, which is also a very tedious task. It's not easy to add 6 vectors. It will take some time to add 6 vectors at a given time, and these vectors may be the function of time, because the internal forces can change the velocity of individual particle. Internal forces cannot change the velocity of the center of mass, but they can change the velocity of the individual particle. So these quantity may be function of time, they may depend on time. So it's require a superhuman ability to solve this term. But what is this term? This is actually the total linear momentum of the system, because these are the linear momenta of individual particle and their vector sum is the total linear momentum of our system So dear student, this term is total linear momentum of our system. Now student, let's look at the left side. What is this? This is a single term, m mass of the system, dr by dt is the rate of change of position vector of a point which we defined yesterday, and the name of that point was center of mass. So student, let's give it a name. In analogy with this expression, we can call it as, or we can define it as the velocity of center of mass. So student, m is the mass of the system and v vector is the velocity of the center of mass. And student, m into v, we can define it as linear momentum of the center of mass. So student, we can represent it with or denote it with p vector, and right hand side is your total linear momentum of our system. So student, it's very cumbersome task to calculate these individual quantity and then adding them vectorically, but we escape from this cumbersome task by using just one relationship or one equation or one quantity. We need not to go individually to every particle because their vector sum comes out to be equal to this quantity, and finding out this quantity is very easy because this equation is like a single particle. So we need not to go to consider the 10 to the power 6 particle. We can easily find out the vector sum just by calculating the mass of the system and velocity of the center of mass and simply multiplying with each other. So student, we have defined a new quantity p, which is the linear momentum of center of mass and which is equal to the vector sum of all the individual momenta of the particles. Student, we also come across, in yesterday lecture we also come across another equation which was the Newton's second law for our system of particle, and that equation was m, the second differential of our vector r with respect to time t equals the total external force on the system. Dear student, we can write it as m d by dt into dr by dt equals the external force vector, and we define this quantity as velocity of center of mass. This can also be written as d by dt of m v vector equals our external force. Dear student, here its m can be taken inside this differential, and dr by dt we have already defined it as the velocity of center of mass, and m into v is defined as the momentum of the center of mass. Then student, you will get dp by dt, the rate of change of linear momentum of our center of mass, equals the vector sum of external forces acting on the system. Now student, our topic is conservation of linear momentum for a system of particles. Student, if there is no any external force is acting on the system, or the vector sum of all the forces acting on the system is 0, there are two conditions. In first line I am saying if there is no any force, the system of particle is in outer space, there is no any kind of interaction, no any kind of fields is there, no any other object is there. And the second is, if we have a system of particle which is being acted upon by 3 external forces, but the vector sum of all these 3 forces is 0. In both these conditions, I can say Fe equals 0, then this equation implies that P equals constant, because the differentiation of P 0 means it implies P is a constant vector. Means if there is no any external force, the linear momentum of the center of mass, please keep in mind, the linear momentum of center of mass is constant. It cannot change. Dear student, let's come to our yesterday's example, which was exploding cell. Students say it's a cell and it's going to explode, and the role of the explosion is just the internal. There is no any external role in this explosion. In that case, we can see it's after explosion it turns into so many fragments and they move in different directions, but the center of mass will remain at the same point. The fragments or the parts of this cell will move in such a way that if a particle moves in this direction with certain momentum, then there must be equal and opposite momentum in this direction, so that their net momentum is 0, because the center of mass is located before the explosion and after the explosion at the same point. Dear student, it was our conservation of linear momentum of system of particle. You may take it screenshot, and thanks for watching the video.